So in this equation you have to solve for x, and the equation is 8 raised to the power x minus 2 raised to the power x, and this divided by 6 raised to the power x minus 3 raised to the power x, and this is equals to 2. So this is a exponential equation in which you have power terms, that is 8 raised to the power x, 2 raised to the power x. So how will you solve this problem? Now see, one common thing that you can find in this problem, that is you have something like 2 raised to the power x or 3 raised to the power x. For example, here you can write 8 as 2 raised to the power 3, which can further be converted into 2 raised to the power x. Similarly, 6 I can write 3 into 2, and you have power x. This can further be converted as 3 to the power x and 2 to the power x. So let us first simplify this expression. So I can write this is 2 raised to the power 3 raised to the power x minus 2 raised to the power x divided by 6. I can write 3 into 2 raised to the power x, and this minus 3 raised to the power x is equals to 2. Now if I use the rules of power, that is if you have a raised to the power m raised to the power n, this can be written as a raised to the power m times n, which can further be written as a raised to the power n and raised to the power whole m. So basically the exponent interchanges. Here you have m inside the bracket, but here you have m outside the bracket. Similarly, n is inside the bracket, but this is outside of the bracket, but here you have inside of the bracket. So this means I can interchange the position of exponent. So I can write this is 2 raised to the power x raised to the power 3 minus 2 raised to the power x, and this divided by, so this term I can further use the rules of power for this term. If you remember, if we have a times b and raised to the power m, this can be written as a raised to the power m times b raised to the power m. So if I use this rule, I can rewrite this expression, that is 3 raised to the power x times 2 raised to the power x minus 3 raised to the power x, and this is equals to 2. Now let us see what you can do next. You can now further simplify. So this becomes, basically you can take 2 raised to the power x common, because you have 3 and here you have power 1. So this is what? If nothing is written, then this means this is power 1. So you can take basically 2 raised to the power x common. So let us take 2 raised to the power x common. So this will become 2 raised to the power x raised to the power 2, and this will be minus 1. So I hope this is clear to you. And here I can take 3 raised to the power x common. So this will be 2 raised to the power x minus 1, and this is equals to 2. Now you see, some important things are coming here. Now this term is a square minus b square. This is a, then this is a square, and this is b, then this is b square. So now I use this formula, that is a square minus b square is equals to a minus b times a plus b. So let us use this formula. So if I will use this formula, I can rewrite this expression. So this will become 2 raised to the power x, this is as it is, and then this is a plus b and a minus b. So this is a minus b and this is a plus b. And this divided by 3 raised to the power x and 2 raised to the power x minus 1, and this is equals to 0. Now we can basically cancel out these two terms, but for that this should not be 0. This means I can cancel only if 2 raised to the power x minus 1 is not equal to 0. This means 2 raised to the power x is not equal to 1, which is equals to 2 raised to the power 0. This means x is not equal to 0. So I have to basically prove that in this question x is not equal to 0. So let us see here. If you consider the denominator, if x is 0, what will happen? 6 raised to the power 0 is 1, and then 3 raised to the power 0 is also 1. So 1 minus 1 you will have in the denominator, So any function in the denominator 0 is not defined. So I cannot have x is equals to 0. So for this problem, one thing is known, that x is not equal to 0. So now I can cancel. So after the cancellation, what is left? We have 2 raised to the power x, 2 raised to the power x plus 1, and this divided by 3 raised to the power is equals to 2. So let us take this 3 raised to the power x this side. So if I take this side, so this will be 2 into 3 raised to the power x. Now you can further take 2 this side, so this will be 2 raised to the power x divided by 2, and this is 2 raised to the power x plus 1, and this is equals to 3 raised to the power x. Now this is a raised to the power m divided by a raised to the power n, then this is a raised to the power m minus n. So this I can further simplify. This is nothing but 2 raised to the power x minus 1 times 2 raised to the power x plus 1, which is equals to 3 raised to the power x. Now let us consider this equation, and we will see how the solution we can find using this equation. So now we will consider different possible cases for x. So let us say we plot a number line here, and on this number line we have x, and this is x equals to 0, but in this problem we know that x is not equals to 0. So this case we have already considered, that is x cannot be 0. Now let us consider x is equals to 1. Now if I consider x is equals to 1, that is the second case, can we find any solution? Now see, this side of this equation 3 raised to the power x, that is basically an odd number, and this is also an odd number, and this will be an even number because 2 raised to the power something, and x is positive, so we are considering positive side of x. So this side, we will consider negative side soon. So this is also a even number. So if I consider, now see x equals to 1, will this satisfy this equation? So let us check. If we put x equals to 1, 2 raised to the power 1 minus 1 times 2 raised to the power 1 plus 1, which is equals to 3 raised to the power 1. Basically, so this is 2 to the power 0, that is this term 1, and this is 2 plus 1, which is indeed equal to 3. This means this satisfies this equation. This means x equals to 1 is a solution. Now what about number? If I have a number that is greater than or equal to 2, that is not equal to 1. So the third case, if x is greater than equal to 2. Now as I said earlier, if you have a number that is greater than 2, in this case you will see 3 raised to the power 2, that is 9, or any number. If x is any number that is greater than equal to 2, this will be odd. Similarly, this will also be odd. 2 raised to the power 3, 4, even 2 raised to the power 2 and plus 1, this will be odd. And this will be even. Let us say 2 to the power 2, 3, 4, and but you have to subtract minus 1 here. So this will be even. So if you consider 2 equal to x equals to 2, then this will become 2 raised to the power 2 minus 1, that is 2 raised to the power 1. So now in this case you will have no solution because you have even this side and you have odd this side, and this side is odd. So even multiplied by odd will never be odd number because it will be an even number. So in this case, no solution. So in this case you will have no solution. Now the third case that is left, so we have considered this side of the number line, that is this side. We have considered whole number line this side. Now let us consider this side of the number line, that is x is negative. So the third case, or basically in fact this is a fourth case, if x is less than equal to minus 1, because x cannot be 0 and it is given in the question that the solutions are integers. It can be positive integer or it can be negative integer. So let us say in this case I can write x as equals to minus n. X equals to minus n. So what was the original problem? This was the original problem. Original problem was 2 raised to the power x minus 1, and this multiplied by 2 raised to the power x plus 1 is equals to 3 raised to the power x. Now let us substitute x equals to minus n and see what happens. So if you substitute x equals to minus n, so this will become, let me write here, 2 raised to the power minus n minus 1, and this will be 2 raised to the power minus n plus 1, and this is 3 raised to the power minus n. So this will be 1 by 2 raised to the power n plus 1, and this will be 1 by 2 raised to the power n plus 1. And I hope that you understand these steps because I am simply following the rules of power, and this will be 1 by 3 raised to the power n. Now I further simplify, so I can rewrite this expression as, so this will be 1 by 2 raised to the power n plus 1, and if you take LCM, so this will be 2 raised to the power n, 2 raised to the power n plus 1, and this will be 1 by 3 raised to the power n. Now see, what we can do is 3 raised to the power n, let us cross multiply 3 raised to the power n multiplied by 2 raised to the power n plus 1, and this will be 2 raised to the power n and 2 raised to the power n plus 1. So power gets added, so we will have 2 raised to the power 2n plus 1. Once again you can check. Now n is positive because we have considered x equals to minus n. So n is a positive integer. So this number will be an even number. 2 raised to the power some positive number. Now this is an odd number. 2 raised to the power n plus 1. N can be a number 1, 2, 3, 4 because n is positive. So this is odd. And this is 3 raised to the power n, that is also odd. So this means even cannot be equal to odd times odd. If you multiply two odd numbers, it will never be a even number. This means in this case you also don't have any solution. So no solution in this case also. So no solution. So in conclusion I can say x equals to 1 is the only solution for this equation. We investigated the whole number line for integers, and in this case 1 is the only solution. So I hope you enjoyed this video, and if you enjoy, please share with your friends, like this video and subscribe to my channel. Thanks for watching this video. I will see you in the next video. Thank you.